Hi, I'm Jackie with Developing Mathematical Thinking Institute, and today we're going to talk about equivalent fractions. So when we think about equivalent fractions, there's several things that kids will have experienced prior to what we're going to talk about now. So the first idea is just understanding fraction language. You can see the video from Jonathan earlier talking about that language that we want to experience with fractions to help with what we're going to look at today. The other thing to think about is kids have also experienced seeing fractions in the same spot, maybe on a number line and on a bar model for the first time. So they grapple through those ideas and then get to this more formal idea that we're going to talk about right now. So if I start with a fraction like 1/2, and I take that unit of 1/2, and I'm going to take that and I'm going to partition my halves in half. All right, so now by doing this, I've created units of 1/4. And if students are not quite sure what those units are, we can go right back to that fraction language that Jonathan had referenced and talk about, well, how many of these equivalent units does it take to compose 1? Since it takes 4 to compose 1, now I have units of 1/4. So I can go ahead and label those. All right, so with equivalence, we're going to talk about what changes and what stays the same as I go from talking about 1/2 to 2/4. So that change from 1/2 to 2/4. So first we're going to talk about what stayed the same, because oftentimes when we're talking about equivalence, that's really where our focus starts, is what's staying the same. And if we think about what's staying the same, it's that shaded portion that we're talking about. I didn't shade any more of my bar model. I didn't erase any of the shading. It's that shaded amount that's staying the same. The other thing that's staying the same, what's a really important idea with equivalence, is to think about that unit of 1. And we're still comparing that same unit of 1. Again, so those are our two big ideas that are staying the same with equivalence. The part that we don't talk about as much, though, that really highlights some really important mathematical ideas is what's changing. So we're going to take a look at what's changing with equivalence, because there are some things that are different. If you think about it from a student perspective, we're asking them to make sense of how 1/4 and 1/2 and 2/4 are the same thing, but the numbers completely change. So we've got to address that idea as well. So we can go back again to that fraction language and we can talk about how each of these ideas has changed. So first we're going to attend to that denominator, which really defines that unit. So when we think about that, we take that unit size, and when I partition those units in half, the units are half as big. Well, in that same moment of making those units half as big, I now have twice as many units to compose 1. So we see that inverse relationship between these two things, the size getting half as big, or the number of units to compose 1, I have twice as many. Now, in order for it to still be equivalent, that means I also have to increase my count. So if I'm going to have pieces half as big, I'm going to have to count twice as many of those. So I'm going to double the count. We eventually formalize this into an algorithm many of you may remember that looks like this. So let's talk through that algorithm. I'm taking my 1/2, and that 2 in the denominator is taking my units in 1/2 and partitioning them, making them half as big as they were. That's those blue lines and those partitions. But it also gives me twice as many units to compose 1, again, related to the size of those units. Then the 2 in my numerator doubles my count. So instead of counting 1 of those larger pieces of 1/2, I'm going to count twice as many, or 2 of my smaller 1/4 units. We'll talk later about how this ties into some ideas with multiplication and how we're starting to set the stage for that with this. But again, it's nice that we can also use that fraction language as we do this. Thanks.